Hello chemists, this is Miss Placino and you are watching Screencast 5.2 on naming covalent compounds. Today's lesson is going to be very similar to yesterday's, except instead of looking at ionic compounds, we're going to be working with covalently bonded compounds, also known as molecules. So we're going to focus on how we can name covalent molecules and how we can determine the chemical formula just by looking at the name. We started off class with this do now. Why is it beneficial to have a standardized naming system? What problems might we run into without one? And as a class, we kind of came to the conclusion that having a standardized naming system is really going to help with communication. If people are just allowed to name molecules and compounds whatever they want to, it's going to be very difficult to communicate. You'd have to memorize the names of thousands of different compounds and molecules, or you'd be constantly looking them up, and that would be really inefficient. So we have a standardized naming system really to aid in communication and just to make sure that when people are talking about molecules, they're on the same page. The name of covalent molecules, especially the small molecules that we're going to discuss, follow very specific naming rules. All right, so let's get into today's lesson. We're going to look at binary covalent compounds. So binary covalent compounds are going to be covalent compounds that are made up of just two elements. Of course, there are covalently bonded molecules out there that contain more than two elements. You took biology last year. You probably remember glucose, C6H12O6. That molecule belongs to like a different naming system, or a different set of rules are used to name it. We'll be talking more about those rules when we get into organic chemistry much later in the school year. But for now, we're always going to be looking at compounds that only have two elements if they are covalent. Let's take one you are probably very familiar with. CO2, we know that's called carbon dioxide. If you had to explain to somebody how you named it, well, all right, looks like the first element, the first nonmetal listed, keeps its name. That's carbon. We know that O is oxygen. And just like with ionic compounds, we're going to drop the ending and we're going to add "ide." You might be wondering, well, how do I know exactly where I'm supposed to cut off the name? And really, if you just say it aloud and it sounds kind of funny, then you know it's wrong. For example, it's oxide and not oxygide. That doesn't make any sense. So usually it's like the last syllable that gets cut off. But again, just say it out loud. If it sounds kind of silly, then that's not right. The prefix di, that comes in because there are two oxygen atoms present in this compound. This is something that we don't do with ionic compounds because the charges of the cation and the anion have to exist in this very specific ratio in order for that compound to be neutral. However, we know that there is not just carbon dioxide, but there's also CO, carbon monoxide. All sorts of spelling issues today. Monoxide. The prefix mono is telling us that there's just one carbon atom. We don't have a subscript for one, but no subscript is implying that one atom is present. So since nonmetals can combine the same two nonmetals in multiple ratios, we need to communicate how many of each atom are present. So we'll talk a little bit more about the prefixes in just a minute, but to kind of summarize, the first nonmetal listed is going to keep its name. It's generally the one with a lower lower electronegativity. The second nonmetal is going to end in "ide. And we're going to use the prefixes to denote subscripts. Let's say you have the name dinitrogen trioxide. Well, hopefully you see nitrogen and oxygen right off the bat, so we'll call that N and O. The prefix di means two, so we must have two nitrogens. And the prefix tri means three, so we have three oxygens. And sure enough, we end up with the formula N2O3. Remember that the prefix that is given denotes the number of that atom present in the compound. So again, we've got two nitrogens and three oxygens. That's where the di and tri come from. Hopefully you got them from your reading. Backtrack for just a second. When you are naming covalently bonded compounds, you do not want to reduce the formulas to the simplest terms. You need to keep that ratio just the way it is. Do not try to simplify it. Again, if you think about glucose, C6H12O6, that has not been reduced down. It would be incorrect to say that CH2O is glucose. That does exist, but not a sugar. That's going to be like formaldehyde, which is obviously a very different molecule. So we don't want to reduce the subscripts down. We want to keep them exactly the way they're presented in the name. So as I was saying before, from your reading last night, hopefully you got the prefixes, but just to review, the prefix for 1 is mono, and that O is in parentheses because sometimes it can be dropped. We'll talk about when that comes up later. 2, di. 3, tri. 4 is tetra. 5, penta. 6, hexa. 7, hepta. 8, octa. 9, nona. And 10 is deca. The reason we've got the ending vowel, if it's an A or an O, in parentheses, is sometimes it ends up being dropped. For example, we talked about carbon monoxide. We wouldn't write, and we're going to fit that in there, carbon monoxide. That's kind of awkward to spell and awkward to write, so we just drop one of the two vowels. We always drop the one associated with the prefix. In the case of mono, it doesn't really matter. They're both O's, but we would just say carbon monoxide. If it was tetraoxide, again, a little bit awkward with the two vowels, one right next to another. So we're going to drop the A, and we would just say tetroxide instead of tetraoxide. If you make that mistake on a quiz or a test, we're still learning how to do this, so you're not going to be penalized for it, but just be aware that you generally will not have those two vowels right next to each other. We can use all of the prefixes for both the first and the second element listed, with the exception of mono. We do not use mono for the first element. We don't say monocarbon dioxide or monocarbon monoxide. That's not put in there. So if you only have one atom of the first element, you do not use the prefix mono. That only is used for the second element listed. The other 9 can be used for either the first or the second element. So let's try some practice. Pause the video, use your reference table, see if you can either provide the name or the formula of these molecules. All right, first up we have SiO2. Si is silicon, which is a metalloid, and for the sake of naming, just like with bonding, we're going to treat metalloids as though they are nonmetals. The name of this compound would be silicon dioxide. SeF6, that's selenium hexafluoride. We talked about CO a bunch of times already today. Carbon monoxide. CCl4 is carbon tetrachloride. Diarsenic pentoxide. The prefix di means 2. Here's a case where we drop the A off of penta just to make it pentoxide. That prefix means 5, so we get As2O5. Phosphorus triiodide is Pi3. Sulfur dioxide, SO2. And finally, dinitrogen tetroxide is N2O4. And notice how this has not been reduced down to lowest terms. You always want to keep covalently bonded compounds, also known as molecules, with the same ratios that are provided in the name. Do not simplify. There are a couple of compounds that we're going to talk about this unit that don't have a systemic name. So instead of naming something like H2O, dihydrogen monoxide, of course we don't call it that. You know from, my goodness, well before you got to high school, the H2O is water. The reason we have compounds that don't have these systematic names is because they were just named well in advance of the advent of the naming system, and people just weren't going to change them. So these have common names, so it is incorrect to call water dihydrogen monoxide. Ooh. NH3. What's that? Let's go back over here. We don't call this nitrogen trihydride. That's what it looks like it would be called according to our naming rules. This is one of the common name substances you need to know. This is ammonia. You probably have ammonia at home if you have like a window cleaner. It's really good for cleaning. And finally, CH4 is not carbon tetrahydride. We use this in the lab for your Bunsen burners. You might have heard me say it a couple of times by now. We call this methane. So again, these are the names excuse me, of these 3 compounds. Do not name them according to the techniques that we've been talking about so far. It is incorrect to call them any of those three names. We'll use water, ammonia, and methane. On something like a quiz or a test, you know that I'm going to have you name these things, and I'm going to try to sneak in one of these three compounds after you've named a bunch of covalently bonded compounds to see if I can get you. Don't fall for that. Most people don't fall for water, but the ammonia and methane get forgotten. So unfortunately, those are just going to have to be committed to memory. All right, let's wrap up with a 60-second summary. Take a minute or so and write a 2-sentence summary of today's lesson. In addition, if you take a look in your workbook, you'll see that you have a ton of naming practice problems. I know that looks really overwhelming, but naming is something that you have to do a lot of before you get good at it. So with the practice problems, before you just dive right in and start to name it, the first thing you want to do is determine whether the compound is ionic or covalent. If you see a metal present, surefire dead giveaway that it is an ionic compound. If the first element listed is a nonmetal, that of course has to be a covalent compound. At this point in time, if you see more than 2 elements listed, it is going to be named as an ionic compound. We know if an ionic compound has 3 or more elements in it, there must be a polyatomic present, and we don't know how to name covalently bonded molecules that have more than 2 different types of elements. So just a couple of tips, and definitely keep on practicing with naming. All right, that is it for today's lesson. I hope you found it helpful, and thanks for tuning in.